Welcome to episode 2 of our series on process safety in the chemical industry. Today's topic is one of the most fundamental elements in process safety: hazard identification and risk assessment. Understanding hazards and managing risks is the foundation of accident prevention in the chemical industry. Many incidents happen not due to unknown dangers, but because known risks weren't addressed. For example, something as small as accumulated solvent vapors near a hot equipment can trigger a devastating fire. A hazard is anything with the potential to cause harm to people, property, or the environment. Hazards must be evaluated at every stage, like raw material handling, processing, and waste treatment. Each type of hazard plays a role. A rotating shaft without a guard, or a manual valve left open during startup, both are common but dangerous oversights. Risk isn't just about danger, it's about how likely it is and how bad it can be. For example, a vessel explosion might be rare, but if it happens, the consequences are catastrophic. On the other hand, a frequent solvent spill might seem minor, but repeated exposure can lead to fire or health hazards. This is why we use a risk matrix to make risk visible and comparable. There's no single tool for hazard identification, each method serves a different purpose. Imagine a pump tripping during solvent transfer. What if analysis helps prepare for this? Similarly, HAZOP might flag high pressure buildup due to a blocked line. HAZOP is a structured technique used to identify process hazards and operational issues. A multidisciplinary team studies the process line by line using guide words like more, less, or none to evaluate what can go wrong. It's detailed and time-consuming, but extremely effective for complex systems and new designs. What if analysis asks simple but powerful questions? What if a pump fails? What if an operator opens the wrong valve? It's a flexible tool, great for smaller teams or early project stages. While not as detailed as HAZOP, FMEA focuses on individual equipment or systems, like pumps, sensors, or control valves, and evaluates how each component could fail. We look at what the effect would be, how likely it is, and how detectable it is. This helps us prioritize improvements and plan maintenance activities. JSA is used before performing a task, especially in non-routine or high-risk activities. It involves breaking down the job into steps, identifying hazards, and setting safety measures for each. It empowers workers to understand and mitigate risks in real time, fostering a safety culture. A dust explosion may be rare, but its impact can be fatal. A risk matrix highlights this as high priority despite low frequency. Risk control starts with elimination, that is, removing the hazard entirely. If that's not possible, we substitute it with something safer. Next, we apply engineering controls like containment or automation to reduce exposure. Administrative controls, like procedures and training, help manage behavior. Finally, we rely on PPA as the last line of defense when other measures can't fully protect. In the next episode, we'll discuss how multiple safety layers, like alarms and interlocks, can prevent incidents. Don't forget to subscribe and share your own plant stories in the comments.